Hello, Professor Dr. Raphael Fan, Ying Low, and everyone. Today I will be presenting for FI3183 Malicious AI for the assignment Milestone 3 Champions of the World. This is from the team Light.ProjectedDownfall. So here are some of the details for our team, for my team. We are on the light side or the defender for the project, for the assignment, which means that our goal is to detect or prevent some kind of an attack which is done on or by an AI. So in this project, we are mostly focusing on generative adversarial networks, but I will give you the details a bit further later on. And my name is Muhammad Aiman bin Shamsiemon. So here's a bit of a summary on the project details of this project. This is based on a research, which is topic towards deep learning model resistance to adversarial attacks, which is described in the research papers there. And here are some other links which are related to this assignment, to my assignment that I did. I will provide the link later on in the description of this video. So here is the crux of the project essentially, which is adversarial attacks. So what happens right now is that an AI is detecting Panda, which is with a 57.7% confidence. And what happens is that someone or an algorithm changed this photo with minimal perturbation. So what that means is that the the changes are not enough to be are usually not enough to be detected by a human, but it radically affects the images such that an AI would then detect the photo as something else. In this instance, it detects the panda initially as a gibbon with a very high percentage confidence. Do note that in this example, you can see that the AI initially detects the panda with a 57.7% confidence. So that is something to keep in mind. So let's go into a bit of more into details about the papers that I have used in this project. So the first paper is the topic of this project, which is towards deep learning models resistant to adversarial attacks. So what this means is that, remember the example earlier that we showed, so this paper suggests that there's a type of adversarial attack which is good at generating strong adversarial network that can fool the model with minimal perturbation. And what the paper suggests we do is that we purposely, while training the model, we include examples created by these adversarial attacks so that the model in essence would be resistant to changes introduced by these models. So this paper attempts to prove that models trained with PGD can achieve a greater accuracy for identifying adversarial generative examples than FGSM. So, and what this paper attempts to answer is that it attempts to say that the first equation on the top here can be solved effectively using the second equation down there, which is for the projected gradient descent, the method used to train the models. So here are the result of this paper. You can see that generally the adversarially trained model is able to detect adversarially generated examples with a relatively high frequency given the a certain epsilon value. So when the epsilon value is here, it indicates that when epsilon value is equal or the same as the one that is used in this training, is generally able to predict the adversarially generated example quite relatively well. And here it shows how the accuracy of the model for adversarially generated attacks is relatively high. So there is a chance that we can sort of train AI to be resistant to adversarial attacks. And here's the second paper that I'm focusing on for this project, which is fast is better than free. So what it shows in this paper is that fast gradient sign method is actually weaker than projected gradient descent, but at the same time, it requires less computational power. So in a sense, it's cheaper. So even though models trained with FGSM, which is a weaker adversarial attack compared to PGD, the effectiveness of the model, the resistance of the model towards adversarial generated example is relatively the same, or even about as effective as PGD, and with a relatively less computational cost. So here it shows that the FGSM training with random initialization is just as effective as PGD training, and in some cases even faster. So here is my approach for this project. So here is the model that I use for this project, which is using LeNet 5. And in this project, I'm mainly focusing on training the model to recognize numbers using MNIST dataset. So using this dataset, the model is expected to be able to classify numbers. So I'll show you an example later on, but it will be able to identify numbers from images, and it will able to do this even if the data has been adversarially attacked. So it has been changed by some method, and a human can't recognize it, but a robot can. And the model I am aiming for should be able to still recognize the same image even after being changed. So that is what I'm aiming for. So using with the topic at hand, I'm also planning to train this model to be resistant to adversarial attacks using projected gradient descent. So here is the training code, basically. So it's trained using MNIST dataset with 128 photos, and this is done 4 times or with 4 epochs, and the accuracy is then analyzed at the end of each epoch. So you want to see that the accuracy increases at the end of each epoch. So here is the code for the adversarial side of the training, which is using PGD. So each photo is then adversely changed using projected gradient descent, and then the model is classify them, and then in this method we sort of train the model to be able to recognize even adversarially affected imagery. So here is the result of this project. So we are able to, for unaltered in MNIST data, we are able to get an accuracy of 98.74%, which is higher than the one shown in the research paper. And we managed to train the model to identify adversarial MNIST data generated using PGD. So when the data is generated using projected gradient descent, the model is able to identify 91.831% of them. Here are the sort of like the before the adversarial training, before the model was trained on adversarially generated examples, the model was able to identify 5.854%. After that, it is able to identify 91.831%. And this shows how the assertion made by the first paper is quite true, that we can train models to be adversarially resistant, against adversarial attacks. So here in this session, we sort of compare the models and try to see if it's able to identify examples generated using other adversarial attacks. So here, using fast gradient sign method, using momentum interactive method, and Carlini-Wagner L3 method. So generally what I found is that examples generated using the attacks above were not able to mislead the model. So here are some graphs relating this. And here are like sort of like how the attacks are done. So basically, you can see that with the fast gradient sign method from the first one is unable to alter the adversarial example labels. So what this means is that the adversarial attack was not able to mislead the model from not identifying the photo accurately. So this is the same for any other type of attack, momentum iterative attack as well, and collinear Wagner as well. So the other adversarial attacks were not able to mislead the model from identifying them. So and thus what this means is that when we compare to what is shown in the research above, we see that training using PGD increases the accuracy of models, and we demonstrate the effectiveness of models which are trained using adversarially generated example, and we are able to demonstrate that these models trained using PGD are resistant against PGD, and we are able to show that the PGD trained model is resistant towards other adversarial attacks method as well. And here, what happens in this section is that I take up an adversarial attack, which is created by another team, and compare it to the defense that I employ in this project. So here we are comparing against Dark.Banana project attack. So Dark.Banana employ a form of adversarial attack known as hop, skip, jump attack. So from what I understand, they employ a more efficient type of attack, a more effective and efficient type of attack, meaning that it's less computationally it's expensive, and at the same time, the effectiveness is more or about the same. So it's a form of boundary attack. So what happens is that in the image, it sort of attacks the edges of the items in the photo. So the AI would then have trouble identifying because the shape of the image is altered slightly, such that it thinks that it's a different item. So here we demonstrate the hop, skip, jump attack, the attack by Dark.Banana on this photo, and we can see that there is somewhat of a slight difference here, especially in the background, and as you can see, the difference is quite stark in here and here. You can see that you can definitely see how the attack targets the boundary of the item here, of the number 1 here. And you can see roughly how it scatters the pixels a bit, and this might make it so that the AI would have trouble trying to see if and we think that it sort of bleeds into the surrounding here. But the model that we trained using PGD adversarially generated examples were able to still predict the model effectively. So even after the attack, the model is still predicted as 1. And the way that we test this is also we get 101 data models from Annie's dataset, and we change each one of them with that Banana's attack. We generate adversarial models, which aims to fool the model into thinking it's a different number when it's not. So we change each of them, and then we test each of them with our model and see if the model is still able to accurately identify the model despite being changed by Dark.Banana's attack. So with no other modification, with maybe slight modification because we requires a bit of resizing for this demonstration because Dark Banyanya's attack requires a different sort of size compared to our models, so it requires a lot of size. So maybe there's quite an effect there, but overall, the Dark Banyanya's attack were not able to fool my model as much. So we got an accuracy of 95.5%, and this translates to about, I think, 5 incorrectly identified labels, and this actually matches, or even is our model is even can you say to be even more effective compared to project identifying adversarial attacks by uh, hop skip jump attack than projected gradient downfall attack. So definitely I would say that our model is able to correctly identify attacks generated by Dark Banyanya's attack. So in the future, these are the things that I wasn't able to do. So I wasn't able to definitively compare between models trained with FGSM and PGD. So in the future, definitely more work should be placed into comparing the FGSM and PGD, comparing how models trained with random initialization affects their effectiveness against adversarially generated examples, and so on. And definitely something I also noticed is that with the best size of 128, definitely we can try to aim for more best size for training and also best size for testing as well. So it is not able to accurately compare PGD trained model with other adversarial attack methods. So I wasn't able to definitively say that the PGD trained model will be able to what the percentages that is able to detect adversarially generated examples by other adversarial attack methods. So in the future, definitely we want to use more adversarial attacks to better track accuracy of models. So more instead of several examples, testing using one examples, maybe we want to try using 100, even 1,000 examples to see how accurate the accuracy of the model, adversarially trained model is. And also we want to try using training the model using other adversarial attack methods and see how the cost benefit, how the effectiveness of the attack, how the cost of effect all play into each other in this manner. So that is all for this side of the presentation. Next, I would like to present on the code of the presentation of the project as well. So generally, I want to show the codes here. Yeah. So this you can access in the description. Yeah. So get the requirements here. This is the models. Getting the training. This is the training accuracy before the adversarial training, after the adversarial training, and yeah, testing the models. This is where we train the models, we test the models against other adversarial attack, and this is Dark Banyanya's attack. We demonstrate it, and this is the part where we test Dark Banyanya's attack. So that is all for my presentation today. Thank you, Dr. Raphael. Thank you, Yin Lo. I think this has been a very fruitful unit so far. That's all for me. Thank you.